Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Moore's Honest Geometry class. Today we're going to continue with our circles, guys, and we're going to talk about angles related to circles. Very important stuff. It's going to be a long lesson, but I wanted to first of all go over some review of what we've already seen and then introduce some new stuff. Okay, a lot of this we already learned before. I gave you a preview beforehand. So now let's just go ahead and make sure we got this down pat. For the central angle, guys, when you have a central angle, the arc is going to be equal to the central angle, regardless of what it is. Okay? When you have an inscribed angle here, guys, inscribed, that means it goes right up against that circle there. All right? When you have that kind of an inscribed angle, the arc is 2 times the inscribed angle. Okay? Now, new things that we're learning. Well, this one we've seen before. I've called it before the exterior angle. It's also called a secant secant. I don't know if you guys remember, but a secant is a line that goes through the circle in 2 distinct points. So this is a secant right here, and this is another secant right here. And the angle x here is equal to the difference of a minus b divided by 2. So it's 1/2 of the difference of a minus b. Why is it a minus b? Because a is the larger arc. So it's the larger arc minus the smaller arc divided by 2. Then you have what's called a chord. You guys hopefully remember what a chord is. I know we just got back from spring break, so some of those cobwebs are in there. But chord is any segment inside of a circle that goes from one point along the circle to another point along the circle, period. If that chord happens to go through the center, then it's called a diameter. Very good. So the chord. When you have 2 chords here that intersect as such, these 2 angles are congruent because they're vertical angles. We know that. But what is that angle? Well, in this particular case, guys, it's the sum of angle A plus B divided by 2, or 1/2 of A plus B. Yes, sir. For secant, and chord, they need to give you at least 2 values. Sometimes they give you the x and the a, and then you solve for b. Sometimes they give you the a and the b, and you solve for x. Sometimes they give you the x and the b. But yes, very good question. They need to give you at least 2 values, sir. Absolutely great question, my man. Thank you. Okay? Let's continue. Tangent chord. Okay. Tangent chord reminds you of what kind of angle? Inscribed. Very good. So guess what? It is exactly an inscribed. What happens here, though, you got to make sure you recognize it. Whenever you have a tangent, remember a tangent is a line that hits, or a segment that intersects a circle exactly at one point. When that one point, or point of tangency, is also a point of a chord, this angle right here, it's not limited to what's inside the circle. Please make sure. This angle right here, this whole angle, okay, it's half of the arc that it intersects. Or in other words, the arc is 2 times that angle. Tangent. Okay, for tangent, it's like an exterior, right? It's kind of like a secant. So it's going to have the same exact formula. When you have 2 congruent tangents here, okay, angle A minus angle B divided by 2, that's going to be the value of your angle X. And X is right in here, and I don't know why I didn't mark it, and I apologize. That's my angle X. Okay? So please be cognizant of that. Yes, sir. Correct, sir. With A and B, you can find X, or if I give you X and A or X and B. You always need two values at least, sir. Okay? And then last but not least, the secant tangent. The secant tangent reminds you of what, or should remind you of what? Of an inscribed? No. Of an exterior. So in this particular case, again, it's 1/2 of A minus B. So the only thing you really have to remember, different than the 1/2 of A minus B, is when you have a chord, and that's 1/2 of A plus B. Now, these are real simple, real simple. The tough part is recognizing and knowing when to use it. Okay, does that make sense? Everyone's good? Okay, good. I'm so glad. All right. Any questions? All right, I'm going to move on. All right, guys, let's just do examples now. I want to find the measure of angle A. So angle A is right here. What kind of an angle is this? It's a secant. So secant, we're talking about 1/2 of A minus B. So that's 1/2 of 80. So angle A is 40 degrees. Go ahead. Yes, sir? You said, isn't it what? Isn't it the right answer that I just put on the board? Yes, it is. Thank you. No, I'm playing. Anytime you have any questions, guys, that's what I'm here for. Come again? Buddy, that's not the formula. Angle A is my X. This is my X. And X equals 1/2 of angle A minus the angle measure, or rather chord measure A minus chord measure B. I don't understand what you're asking. Are you sure, Pablo? Takes guts to ask. Thank you, sir. Okay. Next. Oh, sorry. Sorry. My bad. All right. Now, there's a good one. I want to find angle F. Angle F here, this is a tangent secant. It's like an exterior. So I want to find this angle F right here. So I know that I'm using that whatever angle I'm looking for equals 1/2 of my A minus B. However, I didn't give you the A per se. You know that arc KH is your B, but arc JK, that's your A. Well, how do I find that? Excellent. 360 degrees in a circle minus 160. That has to be 200. Excellent, gentlemen. So my angle F, which is my missing value, that's my X, right? Is going to equal 200 minus 60. Good job, guys. Divided by 2. And yes, that is going to be 70 degrees. Excellent. Very good. Powerful, easy stuff, though. Powerful, though. Very useful on the SAT and the ACT. I know I sound like a broken record, but I think in one of my first videos I talked to you guys about this. Geometry is the SAT pretty much. It's at least 50%, maybe 60% of the test. Okay, geometry is the boss of that test. All right? May I continue, brothers? Thank you, gentlemen. Okay, let's find angle Q. Okay, again, I was given my B, my smaller arc, but what is my major arc here, boys? What's my little A? 260, that's absolutely correct. So I want to find angle Q. So angle Q, which is my missing angle, that's my X, equals 1/2 of 260 minus 100 divided by 2. So angle Q will equal 80, correct? Right, guys? 160 divided by 2? Not that bad, is it? Just got to know when and how to use what formula exactly. All right. How about this guy? Oh, this is a good one. All right. Given segment AB is the diameter of circle O. So that means it does go through the center here, guys. Okay? Because it's a diameter. Arc BD is 20. They've labeled arc BD here for you. Arc DE is 104. They've labeled arc DE here for you. I want to find the angle C, the angle measure of C. Well, I know this is my smaller arc, that's B, but how can I find AE? Very good, my brother. Thank you so much. Since BA, or rather, since BA or AB is the diameter, that means it's a central angle. So that means this whole entire arc is equal to the angle measure of the diameter, which is 180. So what's 180 minus 20 and 104 minus 124? We've got 56. Excellent, gentlemen. So now we know that angle C will equal 1/2 of A, which is 56, minus B, which is 20. So that's 36 divided by 2. So angle C will equal 18 degrees. Not that bad, right? Okay, does that make sense, everybody? Thank you. Thank you very much. Good point. May I continue, gentlemen? All right. Now, example 5. I want to find angle Y. This is a very good one. Angle Y is right now, with the information they gave us, impossible to find. Because these two, AC and DB, they're not diameters. They were not told. You were not told that they're diameters. In fact, I should have made a separate point here. Let's say called it circle O. There, I kind of messed up. Okay, we can't assume things. But they would have to tell you their diameters. Or you'd have to see that it's going right through the center. And it's not. Yes, sir, my brother. Okay, very good point. But is it a central angle? No. So, yes, AC is an angle measure of a straight angle of 180. But it's not the central angle. So I cannot say now, oh, arc ABC is 180, so subtract 47, and now you can find what AB is. No. This guy and this guy right now are impossible to know. However, don't I have arc AD and arc BC? So can't I theoretically, not theoretically, can't I find what this angle X is here? And then once I find what that X angle is, now these are supplementary and I subtract from 180. You with me there, guy? Okay, so how do we find angle X? This is a chord. So angle X equals, go ahead, yeah, 1/2 of 47 plus 29. Excellent, my brother. So that will be, what is that, 76? 76 divided by 2, 38 degrees. So angle X is 38 degrees. But what is angle Y? Angle Y, right, is going to equal 180 minus 38, which would be 142 degrees. So the measure of angle Y is 142 degrees. That proves, though, what you had asked about earlier, and I'm very proud of you. AC is a straight line. However, it's not the central angle. If it was the central angle, my brother, this guy here, this arc here, would have been 180 minus 47. But as we proved, it's 180 minus 38. So good job, man. Proud of you. Yes, sir. Okay. Oh no, angle Y is 142. We did not make any assumptions. We found what this angle was here, right, my man? Well, isn't this a straight line? So that straight line is 180. Angle Y is 180. But is angle Y equal to AB? No. Why? Because it's not a central angle. Do you see what I'm saying, Johnny?
Yeah, but what I was confused about is that I thought that the inscribed vertex had to be like that in order.
But this isn't an inscribed angle, Papa.
Alright,
This is a chord. What I think maybe this would help you. If I had it like this, my brother, okay? If I had it like that, and then I told you that from here to here was 47, yeah, then absolutely. AB would be equal to angle Y here, but it's not. It has to go through the center for it to be a central angle. Okay? All right. Does that make sense? Are you sure?
Yeah.
Thank you, my brother. Okay. Next. How about here? This is an easy one. Chord. Straight up, simple. This time I actually did it correctly. I showed you that you had a center here, and those two lines are not going through the center. So therefore, they are chords. So angle X will equal 1/2 of the sum of the arc measures. So 27 plus 88, that's going to be, what is that, 115? And 115 divided by 2, 57.5? That's exactly correct. Pretty simple, no? That makes sense? Well, if you wanted to find this angle, for example, let's say I told you I want to find angle Y. Well, now you would go 180, because they're supplementary, minus 57.5, my brother. Does that make sense? Thank you, Pablo. Not bad, right, guys? Not bad at all. All right. Now, oh, wait, well. Come on, Moro. There's one more. Pay attention, Moro. All right. What would Y equal? Bless you, sir. Y would equal 1/2 of 57 minus 31. So Y would equal 1/2 of, what is that, 26? So exactly what someone said earlier. Y equals 13 degrees. Very simple. Like I said, it's just really mastering what to use and when to use it and how to use it. That's all this is. May I continue, boys? Yes, sir, my brother. Yes, sir, my brother. What's up, Abel? I'm sorry, my man? Oh, well, hold on. I got to go one at a time. Hold on. So angle Z. Okay. So I want to find what Z is. Z equals 233 minus 127 divided by 2. What's 233 minus 127? 106 divided by 2. 53 degrees is Z. Yes. Does that make sense? Questions, comments, concerns? All right. Now, you had a question on this one, my brother. Okay, I see what you're saying, though. This was kind of awkward, actually. This was kind of awkward. Yeah, this should be there, eh? That was kind of weird the way I did that. I apologize. That's my bad. Okay? That's my bad. But I do want to find why. I want to find basically this arc. It's chord though, right? Now I know that my angle already is 72, so my angle, that center angle, those vertical angles are 72. And that equals 1/2 of 21 plus, we're going to call it y. So multiply 2 to both sides, we got 144 equals 21 plus y. Subtract the 21, of course, and you've got 123 degrees equals y. So that arc would be 123 degrees, gentlemen. Does that make sense, guys? Promise? Talk to me, brother. You sure? Okay. And yes, again, what you had asked, sir, that was completely valid. Very, very ambiguous where I had that 21 before. In fact, I mean, somebody nailed it, you know. He said, well, aren't those vertical angles? So that would lead you to not assume, but to kind of prove, since these are vertical angles, that can't be 21, and it has to be the arc. Give me 1 second and we'll finish up now. Okay, let us continue here, guys, so we can get you home. All right. Next, what do we got here? I want to find arc Z. So this is going to be 32 equals 1/2 of my large arc minus my small arc, which is Z. So multiply 2 to both sides. That is 64. That equals 125 minus Z. Subtract the 125. That is going to be negative 61 equals negative Z. Divide by a negative 1. And Z does equal perfect. Whoever said it nice and early, 61 degrees. Excellent. Does that make sense? I'll take that as a yes. Okay. Now here, this is just an inscribed angle. So arc A is double the interior angle here. So A equals 130 degrees. And I think, not one more. Oh, there's a good one. All right. I want you to find arc AB, which we'll mark in red. And I want you to find arc CD, which we'll mark in blue. Okay? So this is a good one. This is a very good one. This is going to be a system of equations, actually. Because don't we have a chord in here? But don't we have a secant out here? So doesn't the chord formula equal 65 equals 1/2 of, in this case, we'll call ABA and DCB. A minus B, correct? You with me there, my brothers? Wrong. Plus, because it's chord. And then doesn't 24 equal 1/2 of A minus B, my brothers? Does anyone see that? Promise. Got it? Like I said, you got to know how to recognize which formulas to use. Multiply 2 to both sides, and you've got 130 equals A plus B, and you've got 48 equals A minus B. So, easy. Add them. Those cancel. 2A equals 178 divided by 2. So that's what, 89? 860, yeah, 89. So A equals 89 degrees. So arc A is 89. Now that we know that arc A is 89, I can plug it into either one of the formulas that I started with. Either my chord formula or my exterior angle or my secant formula. I'm just going to go chord. So I've got 130 equals A, which is 89, plus B, Subtract 89 to both sides. And what's that going to be? 41? 41 degrees equals B. Is that correct? Yep, that is correct. So now I found arc A, B, which is 89 degrees. We called that our little a. And we found arc CD, which is our B, and that's 41 degrees. Yes, sir, my brother.
What was this equation?
This equation here, my man, was this guy. I plugged it back in, but I used the A value that I found. Does it make sense? Talk to my brother. How did I do it in the first place? When I added these two here together, system of equations, don't the B's cancel? And then I solve for A. Does that make sense? All right, boys. Thank you very much. I hope you learned a lot. And have a great day.